Okay. Hello, my name is Meghana Nambiyur, and I will be showing how to solve for a derivative of an equation using the Derivi-drop method. So grab a piece of paper and a pencil, or in this case a whiteboard and a dry erase marker, and let's get started. So I'm going to start with a simple quadratic equation. So using dy dx is one way of finding derivative of this equation, but with a Derivi-drop method, it's considerably easier, for especially me. So what you do is you first find all the missing exponents, they're actually still there, and missing coefficients. Coefficients, by the way, are the number next to x, or multiplied by x. So, yep. And then, first thing you'll see is 7 is not multiplied by x, so when finding the derivative of this equation, you actually don't need 7 at all, so you just drop that. And then you multiply. The thing about the Derivi-drop method, you multiply the exponent by the coefficient. So 1 times 5 is 5, and 2 times 1 is 2. So 2 and 5. And then you drop the exponent by 1. So 2 minus 1, 1 minus 1. 1 minus 1 is 0. So x to the 0th power is 1. 1 times 5 is just 5. So it just stays 5. And then on this one, 2 minus 1 is 1. X to the first is x. So it's still 2x. And then, of course, you bring down the plus sign. And that is your derivative for this function. Pretty simple, isn't it? So the next problem I'm going to show you is not a quadratic, slightly more complex, but same concept, same method. So for this, I'm going to use 2x to the 3rd minus 7x squared plus 8. So off the top, you already know to get rid of 8. It won't be necessary in the derivative. And for now, you have to multiply the exponents by their coefficient. So for negative 7 times 2 is negative 14, and of course you drop the exponent by 1, so 14x. And for this, you multiply 3 times 2 is 6. Drop the exponent by 1, so 3 minus 1 is 2, so 6x squared. So the answer for this equation, the derivative is 6x squared minus 14x. Okay. So I lined up some practice problems, and you might want to pause the video when I show you these. So there you go. Go ahead and solve those. Alright, so here are the answers. And remember, on all of these, you just drop the number without x, multiply the exponent by the coefficient, drop the exponent by 1, and you've got your answer. Alright, My next concept that I'll be teaching is just doing the same thing but with fractions where x is on the bottom. So for this one, I'll be doing 14 over x. So to take the derivative of this, you can't just cross out 14 and leave it as x. You've got to actually share the coefficient, of course, and then bring it up to the numerator. So the one thing about bringing something from the denominator to the numerator, if an exponent, the exponent becomes negative. So it becomes 14x to the negative first. And then you do the same thing as you do with the normal derivatives. You multiply -1 times 14, which becomes negative 14, and you subtract 1. So it becomes x to the negative second. But you're not done yet. You've got to simplify this and bring x to the negative second back down to the numerator. So over 1, bring it back down, and you get negative 14 over x to the second, and that is your derivative. It's like another rather simple. You've just got to remember that when it comes up, it's negative, and then you got to bring it back down. So there you go. That's one example. My second example is 24 over x squared. Again, same thing, bring the exponent to the numerator. So 24 times x to the negative second. And again, when normal derivatives multiply the exponent by the coefficient, it's negative 48 x, and then you always drop the exponent by 1. So x to the negative third. You're not done yet, you got to simplify. So negative 48 over x to the third. That's your answer, and that is your derivative. So now I'm going to go ahead and show you some practice for this. Go ahead and pause the video on seeing this. Go ahead and solve those. Alright, so here are the answers. If you have trouble following the arrows, just follow the arrows if you can't see the answer. Alright, so thank you all for watching, and I hope y'all understood what derivatives are now, how to do it with normal derivatives and fractions using the Derivi-drop method. And yeah, thanks. My name is Meghana Nambiyur, and ace your test.